Hello again. In this video, I'm going to go over this homework problem from section 3.3. So let me just read through the problem and I'll show you how to work it out. So it says for a data set of the pulse rates for a sample of adult females, the lowest pulse rate is 36 beats per minute. The mean of the listed pulse rates is 71 beats per minute and their standard deviation is 10.8 beats per minute. So part A says, what is the difference between the pulse rate of 36 beats per minute and the mean pulse rate of the females? Well, the mean pulse rate of the females is 71, and so the difference between 36 and 71 can be found by taking 71 and subtracting off 36. And so the difference would be 35 beats per minute. So that's part A. Okay, part B, how many standard deviations is that difference? So the difference is 35, and the sample standard deviation is equal to 10.8. So if you take 35 and you divide that by 10.8, you can see that it would be 3.24 standard deviations. That's how big this difference is, right? 35 is the difference between the mean and this number 36. And that is 3.24 standard deviations away from the mean, right? 35 is. All right, part C, convert the pulse rate of 36 beats per minute to a z-score. Now there's a formula for z-score, right? To calculate z-score, you take the x value that you're trying to find the z-score for, and you subtract off the sample mean, and then you divide that by the sample standard deviation. Okay, so in this case, we're trying to find the z-score for an x value of 36. Okay, and the sample mean happens to be 71. So we're going to take 36, which is the x value, and subtract off the sample mean, which is 71, and we get negative 35, and then we have to divide that by the sample standard deviation, which in this case is 10.8. And so we get negative 3.24. That is the z-score for the x value of 36. Now, it should be no surprise that it is a negative value. When you get a negative z-score, it indicates that the x value is below the mean value, the sample mean. So in this case, the sample mean is 71, and 36 is certainly below 71, and that's why this is a negative z-score. Now the distance between 36 and 71 is 35 units, which happens to be 3.24 standard deviations. But again, when you convert it to a z-score, this x value to a z-score, we actually get a negative number for the z-score, and that indicates that it's 3.24 standard deviations below the mean. Okay, and then part D says, if we consider pulse rates that convert to z-scores between negative 2 and 2 to be neither significantly low nor significantly high, is the pulse rate of 36 beats per minute significant? Okay, well, this pulse rate of 36 converts to a z-score of negative 3.24, which happens to be below negative 2. And so that would be considered significantly low. Anything below negative 2 in this case is considered to be significantly low, and anything above 2 is considered to be significantly high. Okay, and so since this z-score is below negative 2, that is considered to be significantly low. So for example, the female whose pulse rate ends up being 36 beats per minute in this sample would be considered to have a significantly low pulse rate because it's more than 2 standard deviations away from the average pulse rate of 71 beats per minute. Now this is pretty typical Usually z-scores between -2 and 2 are considered to be somewhat normal. We call them normal. And anything outside of that range is considered to be either significantly low or significantly high, depending on whether it's below -2 or above -2. So in this case, this z-score for this particular x value of 36 would be considered significantly low because it's below -2. Okay, so I hope you found this video helpful. Thank you for watching. Bye-bye.